up and try again.
Hello, everybody. Welcome back. Today we're going to talk about strings, loops, and methods. We're going to make an example, one of the problems that implies those three concepts. So, in the past, we have identified a couple of exercises using strings. There are some lectures also about different methods and different functionalities that you can find in strings. So, I would recommend to take a look at those just to recognize the fundamentals of that aspects. Additionally, there is another lecture for loops, and we discuss a couple of different types of loops, the pre-test and the post-test. I'm going to just recap a couple of those concepts in this lecture, but I would like to invite you to take a look at that lecture, particularly that we talk about loops, and take a moment to go and identify the videos that relates with methods. That will be a good practice to identify how to define a method, how to call a method. So in this particular lecture that I'm going to give you right now, it's just how to migrate a concept, a problem that we're going to solve using loops and strings, and then migrate it into a method. So let's go ahead and talk about this problem. So let's talk about characters and strings. A character, remember that is a primitive type. It's one of those 8 primitive types that Java provides. Remember that Java provides integers, long, shorts, double, float, and also provides something called the Boolean, the byte, and the char. That is the character. So those are the 8 different primitive types that Java supports. So here, we're going to talk about characters in particular, since string is a collection of those characters. I'm going to talk about that in a second. Just before that, remember that a character can be, as you can see here, it can be a type, for example, lowercase c, uppercase c, the number 5, the exclamation mark. Notice that all those characters are in single quotes. This is very important because characters are in single quote, and Java will recognize that thing as a char. So be careful with that. Remember that strings, however, in the other side, they have double quotes in order to identify a string. So a character has a decimal value associated with each character that we present here. Not so sure if you remember, but the ASCII table, for example, this one that we're looking right now, the ASCII table gives you just an expression, just an information to let you know that for every character that we have or we can represent in the keyboard, there is a decimal and a hexadecimal value for that. So those values are actually recognized in the computer that will take place in the operating system, or actually in the software that we provided. There's a translation that we call the ASCII table, right? So just in a nutshell, every character that you type in your keyboard or you can represent it has a numeric value. I think this is an important concept. We already discussed this in a different lecture, but I think this is very important, particularly for the problem that we're going to solve today. Just recognize that for every character that we have, there is a corresponding integer value for that. So coming back here, the string is composed by characters. It's a set of characters, and strings is not a primitive type. Okay, strings, if you can notice, is capital S. So that means that all the objects that we have in Java starts with a capital letter. Okay, we're gonna talk about objects later on. I know we have discussed objects a lot of times since the very first day when we talk about system or even scanner or string. Those are considered to be objects, but the reason why I don't really haven't talked too much about object is because there is a chapter devoted for object orientation, right? It's worth mentioning that Java is considered to be an object-oriented programming language. So that's where we are teaching this course right now in Java. It's very popular to have object orientation programming, and Java is probably one of the best programming languages that achieves this goal. Anyway, so strings have methods, or what we call functionalities, right? So every object deals with methods. So we have seen other like methods similar like length, char add, to lowercase to uppercase substring. that are actually in different resources, including your book, including the website, the Java API, right? So this is just an examples of the methods that we have in Java for string. Length give you the total size, the total number of characters that you have in one string. Char add gives you this position, or actually gives you this character in its position I. So when you see char add and then parentheses, inside of that parentheses you give a number. That number represents the position, the character you want to look in the string. Yeah, I'm talking about these ones in particular because we're going to use them in the problem that we're going to solve in a couple minutes. So um, it's just worth mentioning that when you use char add, this method, this functionality will give you back a character. Okay, that is the whole point of this. When you invoke this method, char add will give you back a character. The rest, they're important that we're not going to talk about today, but you're welcome to go and search for a little bit of more information for these methods. How about loops? So we have a chapter devoted from loops, right? So remember that loops allows us to do this iteration, right? So the word iteration makes sense right now because now we have this ability to move, to process step by step in a sequence of values. For example, when you want to process each character from a string or count any series from an increasing order or decreasing order, process elements for an array or a list. We're going to talk about that thing later on. We're going to talk about arrays and linked lists. Yeah. And the notion of iteration is important because in many different programming languages supports iteration, right? Iteration basically has this ability to move or to actually navigate through a sequence or a set of items. Now, we're going to talk about later on about recursion. Recursion is a different concept. Yeah, it looks like a loop, but this it has a different impact. It's more mathematically oriented. It doesn't use any kind of like the for, the while loop, the do while. They uses a different mechanism. So we're going to talk about recursion later on. So in Java, two types of loops that we have is the pre-test and the post-test. As the word is mentioned, pre means before. So basically you check before, you test before certain execution of statements will do. So the while loop, the for loop, they're considered to be pre-test. The do while is considered to be post-test, right? So today we're going to talk about a couple of those later on, but before that, let me just tell you a couple of items that we need to have in a loop. For example, every loop has to need what we call a checker, right? Or a statement, a condition, right? And that for that, it's important to recognize Boolean statement. In previous lectures, we discussed about Boolean statements, is basically true or false, right? So a condition must be true in order to continue executing certain parts of the loop. So if the condition is false, then that is an indicator that we need to terminate the loop and the rest of the iteration should not be executed. I'm going to demonstrate that through an example. The control variable helps us to update the state of the variables in the condition, right? So that control variable is what, like a counter, accumulator, a sentinel. So those are types of control variables. All of them, they have a Boolean relationship, okay? Not necessarily because if it's an integer, it doesn't have a Boolean relationship. Remember that we talk about relational operators like the greater than, less than, greater equal, less than equal, equal, not equals. Those relational operators helps you to basically perform a Boolean statement, a true or false statement when you compare to different ints, to different values. And finally, the update of the control variable is quite important to avoid infinite loops, right? And also helps us to keep going on, right? Infinite loops not necessarily are bad, right? Sometimes you need infinite loop, exactly precisely when you want to interact with the user, with the computer user continuously, right? Sometimes infinite loops are very helpful when we don't know when to stop. Maybe when we have a condition that eventually will be met, but we don't know when, right? So that's when infinites are very important. Anyway, those three items, the condition, the control variables, and the update of the control variables are very important to make an effective loop. Today we're going to demonstrate a couple items with loops and also with strings and characters and eventually methods by using the abecedarian example. This is one of the problems that we have discussed in the past. So let me just give you a description. This problem was taken as an inspiration from Think Java, How to Think Like a Computer Scientist by Alan Downey and Chris Mayfield. Let me just give you the description of this problem. The word is said to be abecedarian if the letters of the words appear in alphabetically order. That means that the letters that you've been reading one by one, the characters, are in alphabetically order, in increasing order, right? You know your ABCs, right? So if you know your ABCs, that will help you a lot. Now, for example, here there's a couple of 6-letter English abecedarian words, right? You're welcome to read them on your own. So those are just example, but if you pay attention, for example, biopsy, right? B goes before I goes before O goes before P goes before S before Y. So that is basically a abecedarian word. So you need to, the condition is the following: write a method. This is the description. So the description of the problem is to write a method called isAbecedarian that takes a string as a parameter and returns Boolean, indicating whether the word is abecedarian or not. There is a recommendation here to use scanner to ask the user for a string to pass it into the method. Then use the print or printed the value, just whatever we got as a result. Now we're going to break this problem into small pieces, and then we're going to translate everything into code, and eventually we're going to migrate it into a method, okay? So let's pay attention on this problem step by step. First of all, we need to identify what is the input and what is the output, okay? So this is what I recommend to my students all the time. So identify what's your input and what is your output. Once you know what's your input and what exactly you're expecting, the rest is kind of easy. You just need to put your ideas in order. So the input is a string, right? We're interested to know if it's an abecedarian word. The string is obtained by the computer user by using scanner. So that is our input. The output is a Boolean value, true if the string is an abecedarian, false otherwise. So here there's a couple of things, pieces of information that they were given to us: the string, yeah, and their Boolean, their return type. So that's our input, that's our output. The next step is trying to solve this problem without touching too much code, okay? So let's try to solve the problem. Let's just define the steps from the recipe. So the whole idea is to process the characters from the given string, right? So the idea, step number one, is to visit one by one each of the characters from the string. And then we need to extract the 2 consecutive characters. Why 2? Because we need to check if they're in alphabetically order, right? The third step is that we need to compare them in case they are increasing order, right? In this case, alphabetically order. If it happens to be that is in order, then we need to continue with the next 2 and so on. Now, if it happens to be that they're not in alphabetically order, then at this point we identify right away that this word is not abecedarian. So I think this is a very unique situation when we identify that the values that are in consecutive order, they're not in alphabetically order, then we can stop this whole process and say, hey, this is not an abecedarian word. If we continue all the way, if we actually complete step number 3 successfully and we arrive to number 4, that means that we reach the end of the string. That means that we process all of the characters that belong to the string. And at this point, it only means one thing: true, the word is abecedarian. So let's try to do computational thinking, right? Here are the same steps, but let's try to brainstorm a little bit on code. For example, when we visit one by one, every time you see visit one by one, or every time you identify that there is something that asking you to process one by one or consecutive order or for all of them, you need a loop, right? That's pretty much what you can identify. So every time you see that, just relation that part as a loop. Here I just put a while. I will give you a different solutions. I will give you also the for solution. But while loop is probably the easiest way just to identify right away. Extract two consecutive characters. So here we're going to use the power of the char@. Char@, allows you to extract those values that we have at index 1 or index 2 or index 3 all the way, right? Now we need to start identifying that we need variables, right? So when you see two consecutive characters, we need to use the variable I, for example, and because the next consecutive value should be in I plus 1. Here's why I put char@ position I plus 1. So we have I plus 1. I will give you an example. For example, suppose that the very first position of the string, that is character at position 0. Now, 0 plus 1 is 1. So we have position 0 and we have position 1. All right, so because I is 0, those are two consecutive values. You don't like that example? Okay, suppose that I is 2. So what is 2 plus 1? 3. So we're looking for char at position 2 and char at position 3. There you go. The third step is to compare them if they are in order. How are we going to know this thing if they're in order? For example, if the character at position I is smaller than char at position I plus 1. Here I just put compare. Every time you see compare, check, test, you need to use the if statement, okay? Because that's what we're doing to make the decision. If, right? Checking if, comparing if, testing if. So every time you see those words, relation that thing with an if statement. Now I put here the less than, and I know what you're thinking, Professor, those are characters. How can we use relational operators with character? You can, as a matter of fact. And this is the beauty of this assignment because we're going to illustrate that part on the abecedarian by using the Unicode values. So the next step, if they're in order, then we continue with the next two. If they're not in order, then it's time to actually identify they're not in order. That's why we need to use the false statement. Now, if we reach to the end of the string, that means that the word is abecedarian. That's what we need to return the true. Obviously, we arrived to step number 4. That means that the for loop was ending successfully. When we mean that it's ending successfully, that means that we already passed the entire body of the loop a couple times, and then we exit successfully, and it's time to return the true. So let's start with the very first lines of code, right? Here is the scanner input equals new scanner. The system.in, remember that the system.in allows you to basically extract the information from the computer user, from the terminal. Yeah, and the next line that we have there is a string s equals input.next line. Notice that we're holding a variable called s, type string, and by using the dot next line, that means that the input.next line will extract that information from the user, the very first line, a string. So suppose that the S is apple, right? Suppose it's apple, that's the string that we're going to have. Obviously, this is not an abecedarian word, but that's the whole idea of this assignment. Let's just start with this first case. So here, what we're observing is that the string apple has basically 5 elements, right? 5 characters, A, P, P, L, and E. I just put a enumeration there just to identify where is located each of those characters in the string. Remember that we start counting at position 0 most of the time in computer science. Java is a zero-base or zero-axis programming language. That means that we start accessing the position 0, the arrays, the strings, and the indices. Okay, we're going to talk about that later on. And the size is, of course, 5. So the next step is probably we need to identify this index, right? So in the index I plus 1. So we're going to use those variables that I was discussing in the previous slide. I will be the very first position, which is going to be 0. And then we're going to have I plus 1, which is 1, right? So the consecutive 2 values, it makes sense here. So here also we're going to declare a variable called answer is going to be true. This value, it will be the responsible to hold the actual answer in case this word is an abecedarian true or false. So here are the other 2 values, I and j, right? I decided to call it I and j just to basically give you a different notion of variables. Here we're playing with two variables, I and j. In the past, we only use I. I'm just incorporating another one called j, right? Why j? Because j is right next to I, right? And those are the variable names by preference in computer programming. So we have I and j. I just changed the names. Instead of I and I plus 1, I just put I and j. But notice that in reality, I and j is, we're going to start at 0, and then j is I plus 1. The next step is start to create the loop, right? We're going to use a while loop, and here is the skeleton of this guy. So what we're going to do now, we're going to have this notion of, as long as we don't hit the total size, the s dot length. Now, I want you to pay attention in this possibility. And here is where many of my students actually kind of fall into this, I guess, error, right? The notion of error. So as long as the I is less than the current size, that means we're going to start at 0 all the way to 5. But notice that this j, ladies and gentlemen, because it's I plus 1, it's going to go one step ahead of us. And we need to be very careful, because notice that the last index that we can access here is the number 4. Yes, I know there's 5 characters here, but the last index that we can access is the number 4. So we need to be very careful when you try to, when you're looping, because you might have this exception called string index out of bounds exception. This exception happens all the time if you don't pay attention in the boundaries that you have in a string or array index out of bounds and whatnot. So in order to avoid these boundaries, we need to always think ahead, right? And subtract 1 from the size, because we know we won't go all the way to the size, because j has to go one step before. So we're going to change that condition as long as I is less than s dot length minus 1 in order to avoid that array index out of bounds. Now there's another condition, right? So the other condition is as long as the answer remains true. If you remember the Boolean statement, right? The answer is equal to true. The answer is a Boolean value. So this is one way to put it. Now notice that there is an AND, logical AND, right? If you remember the truth tables, this one, yeah, in order to make this condition true, both conditions must remain true in order to keep looping. So yes, this is a different combination of items, but as long as the first statement, I less than s dot length minus 1, and the answer is equal to true, both statements must be true in order to trigger this whole loop. So here, both conditions must be true. Now, why we have to condition? That's your next question. Answer is a Boolean statement. The double equal signs is a relational operator, which implies we're going to have a Boolean statement. The keyword true is a Boolean statement. So there's another different ways to mention this in Java by saying, hey, it's answer, right? Because answer will have the true value. So that's a shortcut. You're welcome to go and do whatever I just wrote in the previous slide, but this is more elegant and it makes more sense as long as answer, right? As long as we keep it true. So in other words, we're saying at the very beginning, we want everything to be true. Yes, this word, true, this word is abecedarian. Now, going back to this idea of the stopping criterion, right? When we need to stop this condition, ladies and gentlemen, the I less than s dot length minus 1 is the very first case. That means that we need to navigate through the entire string until we reach the very end. If you remember in the steps that we discussed in previous slides, this will be a step number 4, right? If we successfully get out, right? So if this case is, that means that I basically navigate through the entire string. For example, here you see in your right-hand side, when you say apple, I is at the very beginning, position 0. So I is going to go to position 1, position 2, position 3, until position 3 actually, because it's s dot length minus 1. So if we arrive, if we get out of this condition, that means only one thing, that the word is an actual abecedarian. So that's what case 1 is specifying here. Case 2 is in case one of the character is not in alphabetically order. So basically here we're going to change the state of answer. Remember that true and false, it will be false. So in order to keep this loop running, both conditions must be true. True and true is equal to true. So that's the only way we're going to basically execute this statement successfully. So case 2 is in case we identify that the word was not, the character is not in alphabetically order. We're going to keep this there just for your reference. But at the very beginning, what we're going to do in the first lines of code inside of the while loop, we're going to extract character at position I and a character at position J. We're going to call it A and B, right? At the very beginning, it's going to be A and P, for example, right? Character position I, which is 0, represents A. Character position J is position 1, represents the P. So we have A and P. We're going to store them in some placeholders called A and B, both of them characters. So the next step that we're going to do, let's see, the next step is going to have to check. If you remember, we will have to check if they're in alphabetically order. Now, how can we do this thing? Let me just stop here for a moment and identify what exactly we're trying to do here. Notice that typecasting, right? The int I, right? So here it is, this part. Yeah, so here, what we identify here is this parenthesis that has int. What exactly is this part? So notice that A and B, both of them, they're characters. So here we're forcing Java to give you the numeric value. Yeah, that's what we call typecasting. You probably remember typecasting from the other lectures. But here we're forcing Java to give us the numeric value for A and the numeric value for B. Why? Because that way it will make more sense. Now, where are we going to get those numeric values? From here, the table. Yeah, the table will basically tell you what exactly is the numeric value. Of course, you have this reference, right? This reference, I got it from the internet, right? But this information is basically being stored in the operating system. There is a convention. That's why we have it here. Anyway, Java is smart enough to identify those numeric values. So basically, this statement, Java will read it as this. So you will have the value of character A and the character P, and then you're going to force it. And Java is smart enough to, when it reads this statement, instead of just processing the characters, it will process the numbers. Yeah, does that make sense? Because this variable 97 represents the character A, and 112 represents the numeric value for P. So we're going to ask, hey, is 97 less than or equal to 112? True. Because this is true, then once we have this statement that represents the truth, then we can go into inside of the if statement, right? So the if statement says do nothing. Now, let me just go back a little bit here. So that semicolon that you see there means do the nothing, yeah? So it's not the conventional way, but basically, I'm just wanted to address different styles of programming because I have seen that some of you are been asking me, what does the semicolon by itself mean? It means do nothing. Basically, this is just a waste of statements, right? So I know what you're thinking. Why should I just leave it the semicolon? I'm going to give you a different variations of this method, right? Of this methodology. But right now at this point, just bear with me. I just put here do nothing. That's what I put the comments, do the nothing. So that way we're going to just move directly to the I++ and the J++. This is when you need to increase I and J. Why? Because the else didn't execute the else because, I mean, A is smaller than P, right? So we didn't have to go and visit the else. But here, we just jump directly to the I++ and J++. So what we're going to do here, we just move the I and the J, okay? At this point, we're going to go back to our loop, and we're going to check if we still less than our current size minus 1, and make sure the answer remains true, which is true. So what we're going to do, we're going to visit the next steps, which is we're going to extract character position I, now is P, and then we're going to extract the value at position J, which is now is P, right? And then we're going to compare, and we're going to ask, hey, is the value P, the character P, less than or equal to the value P? So Java, what we'll do says like, hey, is 112 less than or equal to 112? And indeed it is true. So we can continue here and we do the nothing. And after we finish doing the nothing, we're gonna skip the else and we're just gonna move here. We're gonna do I++. So now I is in the position of 2 and J++ is in the position of 3. So next time we visit the loop, remember that we're repeating here, we're going to check if this remains true, and indeed remains true. Why? Because I is less than, in this case 2 is less than 4, and then here we have also answer remains true. Again, we're going to keep here in checking, hey, is the character position I? Yeah, this guy will be P, and then we extract the value position J, which it will be L. Now I want you to pay attention in the next step. The next step basically is saying the following. Hey, is the character P less than or equal to the character L in numeric value, integers? So I don't know, let's see. You transform this into numeric value. You say, hey, is 112 less than or equal to 108? And what do you think is going to happen? Well, in this case, it's false. So P is not after the letter L. Okay, so here, this condition is no longer true. That's where we're going to visit the else, and I want you to pay attention what is going to happen here. Inside of the else, what we're going to do, we're going to flip this value of answer. Yeah, so right in the past was true. Now we're going to change it to false. And this is critical, guys, because once we change this value to false, this is what's going to happen. Of course, we're going to keep moving to the next statement, right? This is irrelevant at this point because when we go back to this condition, the answer is already false. And you know that by logic, right? By using these truth tables, the statement that I less than s.length minus 1 is true. And answer is false, as you can see here. True and false is false. So here at this point, we are done. So this means that we actually exit before time. And the next step is to go to the next statement. Here we can just report something similar like is the word, and then we put here the word that we can have, which is apple, abecedarian, question mark, and then we can just put the answer is false. So how about even example when the string is abecedarian? Here we're gonna check when it is true the word that is given. For example, we're going to pick biopsy, okay? So biopsy, basically, it is indeed, right? You can see here that they're in alphabetically order. Again, we extract the value in that line from the string. We initialize our true value. We initialize our variables from I and J, right? One is I equal position 0, J is I plus 1. We're just making sure we go one more head. The first case is when we need to navigate through the entire string. The second case is when we need to go and check and make sure the value that we identify in the middle of the string doesn't violate the condition of answer. In other words, making sure that everything is in alphabetically order. The next step, we're going to start to extract the value. Extract position 0 is B. Extract position 1 is I. We're going to come here and check. We're going to check if the value that is B versus I, in this case, the numeric values of 98 versus 105. Indeed, this is true. So what we're going to do, we're going to come here and do the nothing. After do the nothing, we're going to go directly and update our variables I and J for one more position. We're going to come back to the while loop, check if this remains true, which is indeed true. We extract the next value. In this case will be position I is I. Position J is O. We check, right? We're going to check if this position I less than O. Indeed, 105 is less than or equal to 111, which is indeed true. So therefore, we're going to move to the next step, which is do the nothing. And after doing the nothing, we increase our position I and J. We go back to the loop. We extract the values, O as a value of I, P as the value of J. We compare. We check if O is less than or equal to P. In other words, is 111 less than or equal to 112? Because it's true, then we go to the next step. which is doing the nothing. After that, we increase our position I and our position j. After that, we loop back. Both of those conditions remain true. That's where we visit the loop again. We extract the position I, which is P. We extract the position J, which happens to be S. We compare. Here we check. We check if the value of P is less than or equal to S, which is indeed true. In other words, is 112 less than or equal to 115? Indeed true. So next step, we do nothing. And then we move to the next step, which is increasing both variables. Again, we loop again. And here we're going to check both of these conditions remain true. And here is going to be the value of S for position I and the value of Y at position J. After this part, we're going to compare and check in here if the values that we have here, which is S less than or equal to Y, which in numeric values represents 115 versus 121, indeed true. So we do the nothing. And then we increase our variables I and J. And I want you to pay attention in the next iteration, because here notice that I reach the very last position, which index wise is 5, right? Remember that the length of this string is 6. But notice that the next condition that we're gonna go when we loop back is 5. Here we're gonna have to compare, is 5 less than s.length, which is 6, minus 1 is basically asking, is 5 less than 5? And 5 is not less than 5. In other words, this statement is false. Because this is false, that basically will exit this condition successfully. And we're gonna print this, is the word and then biopsy abecedarian, and then the answer, because we didn't change the value of answer, you can see here in the right hand side, which is true, it will remain true. So this will print something like this. This is the print out that is been asking. So we're going to talk about methods. For example, the question asked is about methods, and in reality, the method only helps us to divide and conquer, right, or to decompose. So you probably have heard the notion of divide and conquer. Divide and conquer is a technique that instead of solving the whole problems, like big problems, just by attacking the big problems, you break the problems into small pieces. And then you start solving the problems of the small pieces, and eventually you make it a better solution, right? So methods, in other words, help us to make better programs. So we decompose a procedure into routines or into functionality in order to make it more effectively. It's easy to debug. It's easy to have this separation of duties of each method. So each method is responsible for certain things rather to have everything into one thing. So it helps us to integrate process later on. And there's two main pieces of the methods. The one is called method definition. This is when you create something called the signature of the process outside of the main, inside of the class. I want you to pay attention in that distinction. The methods are inside of the main class. When you see public class something, when you open those curly brackets, you establish the scope. Okay, everything that is inside of the scope, in those curly brackets, belongs to this scope of this class. So that is one of the things that many of my students, they don't have this notion, or they get confused because you don't recognize what the scoping is. So methods may contain 0 or 1 or more arguments, right, in the signature. Here we say, it's just an example, public static. You can find this in the very first methods that we're going to create for the next weeks. And then you need to put the return type. The return type basically specifies that this method will give you something back at the time that someone calls it. Then you have the name of the method and then the data type that you're going to have in the arguments in case you need arguments or parameters, right? And you can have multiple parameters. And don't worry, right now this might think like, okay, I remember seeing this in the past. I probably watched that video real quick, but I think I need to go back and read the book or read my resources. And yes, please do so, right? Because here I'm just giving you an overview. This is a very big overview about what is already in the lectures or in the videos or in your resources, right? So I'm going to invite you to take a look at the methods. The only reason why I'm just discussing this item of method here is because I think it looks more convenient if I translate the method, that the whole methodology that I just did in the couple minutes, into a method. I think it's more convenient. And of course, I just gonna mention that method call, we have been doing method call. I don't know if you noticed, but every time you see the string, the char at, dot length, to uppercase to lowercase, scanner, when you have that next int, next line, right? System dot out print line, those are method calls. And the method calls helps us to, because you invoke, you extract, you call those methods inside of those classes. So let's go ahead and continue. And this whole code that we just create in the past minutes, we're gonna try to identify how can we factorize, how can we decompose it and create method. Every time you see something like this, I want you to identify what is the user interaction. The user interaction will help us to keep unified everything in the main. For example, in the main, we have when you ask the user to enter the string, when you extract the string, and when you report back. In this case, every time you see in this square, in those squares in different color, they belong to the main. So we should just start grouping them, right? We're gonna group these guys together. Now, what about the rest? So the rest of this part, we need to identify what is the actual method, right? So this is the task, this big square that you can see here in greenish. Identify the task process to migrate into one main method. They should be outside of the main. That's what I capitalize here, outside, right? To all caps. Make sure this will be outside of the main, inside of the class. So how are we gonna do this thing? So this code, we're not going to touch it. What we're gonna do, we're gonna start to basically put it inside of a method. Notice that what I just create here, I just incorporate 3 lines of code. That's how simple it is. The first thing I need you to pay attention is that I close the curly bracket. That is it's right there, right after the curly bracket on that system out print line. I put the curly bracket. Notice that closes the main. I know it's not numerically this. I should have put some numeric lines, but I'm gonna put that thing on in the video, that I'm gonna put right now in the code. So after that curly bracket that closes the main, I put it in bluish. Yeah, it's a navy blue. The public, the static, and then the return type is the Boolean. Then the name is called abecedarian. It takes a string S, it's a parameter. Yeah. And then we keep everything the same as we discussed in the other methods, exactly the same. Yeah. So just before I close the very last curly bracket, I incorporate another line called return answer. Ladies and gentlemen, I want you to pay attention because in the signature says public static Boolean, and answer is a Boolean, right? That's why we need to use return, because you're claiming that in this method will give you something back, a Boolean, and indeed we're doing that thing. Here we're gonna return an answer which happens to be true. The third thing that I did in the main is what I call. This is method call. What I did in the outside of the main is method definition. What I did inside of the main is called method call. So here I call abecedarian method. Notice that the S that I'm passing, I just pass in the variable S, which represents the string. Yeah, I didn't put string there. I just put S. Now, I know abecedarian is returning a Boolean. That's what we anticipate in the left-hand side of that equal signs, a variable called Boolean, and then answer. Gets is abecedarian with S. Yeah? So we're expecting a Boolean from this method. That's why I incorporate that. The last line is a system out print line is the word blah, in this case S, abecedarian, and then we have the answer. In other words, ladies and gentlemen, what we're just creating here is just a separation of duties. We create a main that interacts with the user. We create a method, it's called abecedarian, that basically computes these operations. So let's go ahead and actually implement these methods. I'm gonna do this just to demonstrate a couple of different solutions, and I'm going to explain them step by step so you can visualize the different flavors of these items, and then we're gonna discuss this later on. Okay, here I just typed the code that we work in the past, right? So I save it in a file called abecedarian.java. Make sure the name of the file should be exactly the same as the name of the class here. Yeah, they must match. So if you're working in certain platform, just follow the instructions where that platform is asking you. Here I'm using code, and then I will just go into my desktop, and I'm going to compile the program that I have in my desktop. After I compile this program, I'm just gonna call it by using Java Visidarian without the .java. So here is asking me a question to enter the word, right? So to enter the word, I'm gonna use first the Apple one. Yeah, we know this is not an vegetarian one. So the answer that we're expecting is the word apple, a vegetarian. That is false. So I'm gonna call this again, and this time I'm gonna call this. I'm gonna have biopsy. We know that biopsy is a vegetarian because they're in alphabetically order. So here we return true. Okay, so now that we have this, let's go back to the code. So here, this is the notion that we were discussing before. So remember that we want to have a method, and this is where I was telling you we need to migrate certain things into a method. So what we're going to do here, we know that at the very beginning, we're going to ask scanner, right, to help us, the class. Here is the main, here is the scope that I was telling you about. So after we ask for the word, we extract the word, and after the word, basically, we need to close this main, right? Here, I don't know if you notice, but there is some kind of highlight of the curly brackets here. So I think we're still missing this aspect. So we're gonna copy and paste this thing. We're gonna cut it and paste. We're gonna cut it here. And before here, we need answer. And I think this is what we did in the last slide, that we create a variable called answer coming from is a vegetarian. I'm gonna pass the value s there, right? So here we don't recognize it's a vegetarian because we haven't defined it. Notice that after, outside of the main, here's when I'm gonna create public static, and then here we need the boolean, and then the name of the method, right? So here is basically when we create the variable. Notice here that the method, everything remain inside of the method, and the only thing that I'm missing here is the return answer. Sorry, that was the only thing, the only piece missing, right? And this works except that we still have to take as a parameter a string s, yeah, in order to make it consistent. So pay attention. In the main, yeah, here's when we interact with the user. We create a scanner. We ask the user to enter a word. We extract that word, and then we call is a vegetarian. Notice that here how code nicely highlights the method call, right? So here it pops out that this guy returns a boolean. It's called a vegetarian. Yeah, it's called is a vegetarian. Takes a string, which indeed s is a string. Here is being highlighted for you. And indeed, here this guy is giving you back a boolean. We're expecting the boolean on the left hand side. After that thing, we only plug and play, right? We just copy, not copy and paste, we basically concatenate. This is the word that I was looking for. We concatenate these variables into the string. So this should work. Let's go ahead and save this program and make sure it's safe. How do you know? This bullet here that you can see here is not, indicates it's not being saved. I'm gonna press Control S, now it's saved. Yeah, and then I'm gonna go to my console, to my terminal. I'm gonna clear my screen real quick. I'm gonna compile it by using Java C. As I said there in that Java. And then after that, I'm just going to run it by calling Java Abecedarian. I'm gonna hit enter. Enter the word apple. I'm expecting false, and indeed gives me false. And then we're gonna have here again with biopsy, and this is true. Okay, that is one way to do it. So here, the only thing we're doing, we just demonstrate everything that we worked in the past. This works. If you run this in different platforms, they should run it, right? So, but I'm just gonna give you a couple other suggestions here. I still don't like too much this answer. I mean, even that is working perfectly fine, but it's a lot of redundancy. I'm not so sure if you notice this. So I'm gonna, in the next minutes, I'm gonna show you how can we reduce this method big time, okay? So here, first of all, remember that I told you about the do nothing. This is useful, right? And this might be working in different things, but I wanted to exercise the semicolon by itself because basically this is what we call an empty statement. An empty statement basically is just there for the sake of execution, but really doesn't do anything, right? For me, I do care about those different items, and I don't like to have it here. I just wanted to express my I guess it's an okay way to basically solve this problem, but I don't like it. Now let's pay attention what's happening here. When we go inside of the while loop, yeah, we basically extract the information, which indeed we did that there. And then we compare, right? If it's smaller, we can continue. Otherwise, we're gonna complain by changing the variables to false. Now, remember that the very last step, even if you change the false, you don't have to update these statements. So these two statements, they're actually true, or we're gonna execute only in case everything is fine. So what I would do, ladies and gentlemen, I will migrate this piece of code inside of the doing nothing. Yeah, because now we can do something. Here, now we can use the if statement as a way to move forward. The value of I and the j, those are the consecutive values. We can do that. Another thing that I can actually change a little bit, notice that here we declare two variables a and b, yeah, and then we still have to typecast it here anyway. So one way to do this is not declare the variable a and b whatsoever. So we can directly just, I guess, just put it here like this, yeah? And that way we don't have a and b whatsoever. And that's another two less lines of code that we have to worry about it. Remember that table? The table of the ASCII values? That one? Yeah, remember that Java recognizes characters as a Unicode value for characters. That's why characters are considered to be primitive types. In other words, you don't really have to force Java to give you this typecasting. This actually works just fine. Yeah, this is another thing that we can just reduce it big time. Another thing that I would do, just for the sake of reduction, I can just reduce this curly bracket. I don't recommend to do this, but because we only have one statement, we can get away with that. That kind of works. I like this version a little bit more. I like it like a 90, maybe 98% more. Yeah. We can still do more improvement on this, believe it or not. And the way we can actually do this, and it's really up to you, right? Again, it's really up to you how to code this thing. You may agree or disagree with me. I don't care, to be honest, as long as you feel comfortable. If you feel comfortable with the very first version, you can keep that one, right? I'm just giving you kind of cool tricks here in order to make it more faster or more simple. Another way to basically do this thing is that we don't have to basically create those variables outside. I mean, those outside, that's okay because those are the control variables. And we should just keep it that way. So another way what I would do is just to keep one variable. So I would just keep here I, and here I will do I plus 1. Yeah, it looks more pro, and that way we can just keep the I variable there. And we don't need the j whatsoever because we always going to go one more step. Having done that, notice that now I only have one statement there. So if that is the case, I don't need to set extra curly brackets. You guys reduce a little bit more. And yeah, that works, right? That works. Now, if you want to go, I like this 99.9%, but still you can actually reduce it a little bit further. And the way we're gonna do this, and this after you practice a lot, you probably can understand this a little bit more. Here I'm answering to return answer, but in reality, it's a Boolean statement, right? So we just want Boolean statement to be able to return. So what we can do here, instead of just declaring a variable Boolean, what we can say that if here inside of the while loop, basically we're gonna return the false, maybe as an assignation of answer, maybe we can just claim to return false immediately, right? And here at the very end, we just return true if we successfully went through the entire string, yeah, and we didn't get interrupted by this return false. That was just in case they're not in alphabetically order, and that'll do. Yeah, that'll basically do. You don't need here answer because that way we can just simply go all the way through this condition. And that kind of looks more simpler. Yeah, we reduce a couple of lines of code, a few to be honest. If you can see now the size of the code is kind of shorter. Yeah, and it's more clean. Yeah, and if you want, if you're one of those for loops fans, yeah, you can actually transform this into a for loop. As a matter of fact, we can just incorporate here instead of a while, we can say for loop, and then this condition shall go here inside, yeah? And remember that we need one extra step. So here, the extra step is located here. I mean, believe it or not, this runs, yeah, this runs successfully. But if you want to be consistent with this decision, that the same format that we just create everything in Java, this should be here. Now, if I do that, notice that Java right away complain immediately, right? You say, hey, this is an else without if or something like that. So I cannot remember what was the error. Maybe it was that. Let me see if I can get, yeah, it says else without it. So you don't need this else. We do need it, professor. But now that changed, the logic changed. If you just want to clean up with one basically line of code, you can just, if you want to return false, you just have to think in the other way around of this. So the character at position I less than or equal to character position I plus 1, if that was the good thing, if it, just to clarify that that was actually what keeps you in order, just think the other way around. What is the opposite of less than or equal? The opposite is to have it greater, right? That's in case is not in alphabetically order. And if that is the case, we can just reduce it like that. You cannot find more clean answer of this like this, right? This is the most effective way. This is how we reduce the entire, I don't know how many lines of code we have, but this guy now basically does all the work that you wanted to do in, I don't know, what is this? 6 lines of code. 1, 2, 3, 4, 5, 6. Yeah, so 6 lines of code, that was enough to actually to reduce that. Now, I'm not expecting you to do this whole thing right now. Don't worry. Say that, Professor, I kind of understand you at the very beginning, but this is a little bit too much for me. That's fine. I just want to let you know how this process of coding can be reduced big time, right? From one step, and then you can later on you can start to factorize certain things until you reduce the entire work, entire method into a very elegant way. I guess the notion here is elegancy of this concept. After this, let's run it. Yeah, let's run this just to make sure everybody is happy with this. So I'm gonna save it. I already saved this. I'm gonna compile. I'm gonna use Java C. Again, Apple. I'm expecting false. If I run it again with biopsy, okay, I don't have to use biopsy. Let me see. A, B, C, D, E, F, G should be true. Yeah, it works, right? It works now with the method call. Now, I kind of like it, but it's okay. This message it is not, I mean, true, right? Computer science is we're weird, right? We talk in code, true, false, while, and things like that. So that's fine. I mean, but if you work with different people, right, with humans, so humans they try to have a different kind of language rather than just the coding that we use. That's fine. I'm proud of the way I talk to my students. When the students talk to me with true, with false, with other stuff, I got excited. Yeah, but this, let's be realistic, right? If we try to communicate with some other human, then that's a little bit not too, I guess, understandable. True. People don't understand true anyway. So what we can do, let me just give you a better way to give you this answer. Notice here in the method call on line 7, we're expecting a true or false statement. Yeah. So we can make a decision here. We can say something like if, yeah, if the answer is true, right? If it's true, that means that we can say something like this. So we can say something more English or more human says. Like for example, we can say the word is an abecedarian word. Yeah, I think it's more meaningful. And we can say also, how about if that is not true, right? If it's not true, we can use an else. And if that is not true, we can say the opposite. Not an abecedarian word. Okay, something like that. I mean, you can leave it with true or false. The only thing that I'm afraid is that people don't try to understand or they don't get to understand what you really means. If I call this guy again, let's just zoom in here real quick. So, for example, if I put apple, apple is not an abecedarian word. Okay, fine. If I put here biopsy, we can say biopsy is an abecedarian word. You see, it kind of makes more is more English oriented rather to be more coding oriented, more programming oriented. It's more user friendly with the interaction with the computer user interaction, and this will help you later on to make better programs, more sophisticated programs to make it more user friendly with the computer user. Now, in terms of code, you can actually reduce this code if you want. Notice that here we can factorize a couple of system out print line. You don't have to do this. I'm just showing you a couple of cool tricks that you can do. Notice that in both of them, you use the system out print line. So here, the system out print line, you're gonna have the result, right? So result. So what is result? We can use this conditional operator. I love the conditional operator. This is one of my favorite techniques. So you can have here, for example, result. Yeah. So what is result? Well, it depends. It depends if this condition is true. If this condition is true, right? If answer is equal to true, if that is true, remember the question mark? Yeah. So we can have this. And then otherwise, we can put the colon here as a way to specify the else. And the else basically will do this. Yeah, we don't need to have this there. Oops, just remove this part. And that's another way you can actually do. Now we can reduce this. Remember that in the code, this is a Boolean, right? You don't really have to check this part. So in case it's true, if that is true, we can just say it's a Vesedarian. We're just gonna reduce the code here. And otherwise, I can put here the following is not. And actually it's taking me space and I hate when those happen. So you can even compose your system of print line here result because we're gonna have S and then we concatenate it with the result. And then we can, if you want, at the end, we can just put here the word there just so we can make it more clean. Let's see, let's save this. I'm gonna clear my screen. Apple is not an Abecedarian word. Biopsy biopsy isn't a visit during work. You see? Different techniques, same result, different strategies. I hope you enjoyed this code the same way I wrote it for you guys, and I will see you next time. Happy coding.